add 9.
Use the
Add
graph.
9?
We subtract 9.
Subtract 9 from the very beginning?
Yes, sir.
I want to point out, does anyone know what form we could consider this? There's two different ways that we could have considered this form. You could call it standard form, but it could also be vertex, right? It's just that your A is 1, your H was 0, and so we didn't have to show the 1 or the 0. That could be a vertex form because, and I bring that up because what is the process when you have vertex form? What can you use? What are these called?
Zero. No, inverses.
Inverses, right? When we have vertex form, we can use inverses to solve that equation. And so we want to notice that this is a vertex form that we can use to solve, use inverses on. So I create a 0. Negative 9 is equal to x squared. Take that square root. Again, we're in vertex form. We're using inverses all the way through. One thing that I do want to emphasize, because I feel like this is a detail that was causing some students struggles earlier, remember the whole point of a square root is that it's the inverse of a square. You don't have to put that in the calculator. The square root and the square cancel. And so I'm left with the square root of negative 1 is equal to x.
Oh, that's it.
Is that it? Does that match the solutions I have over there?
No.
You gotta have a stick.
Okay, first off, I'm supposed to have how many solutions?
2.
A lot of students in first block forgot this detail. Do you need me to write it up higher?
Yeah.
Okay, so alternate, I'll write it over here. So 0 is equal to x squared plus 9, minus 9, negative 9 equals x squared, and take squared. Okay, a lot of students in first block kept forgetting that as soon as I take a square root, I need to write what? Plus or minus. The very next step there. There's got to be 2 roots. There's got to be 2 zeros, so I need to write plus or minus. But again, does that match right now the negative 3i and the positive 3i?
No.
No.
So how am I going to work with this? This is a thing you will have to do on the understanding check tomorrow,
Okay.
where you simplify a square root.
I got a question.
The number does not affect your ability to do them. Let's focus on learning. Nobody knows how to take the square root of negative 9?
You gotta add I.
Well, we don't add an I, but there is an I there.
Oh, you
There was-
3 times
I'm not.
Yeah, you put the square root
It's-
and then you do like negative 1.
Square root of negative
Top
1.
Okay, so I'm going to pause for where y'all are because y'all are telling me the next steps, and that's great. And what were you saying, Liam?
It's 3i.
It's going to be a 3i, but I want you to focus on how to get there, right? It's the reasoning behind it. So remember, negative 9 is negative 1 times 9, right? And then what can we do with that square root now? Break it up into how many?
2.
So square root of negative 1 times the square root of
I mean,
9 now. And remember, this is important because we wrote those rules about separating into factors of negative 1 and factors of perfect squares so that you can take the square root, right? Not every factor will be a perfect square, and that's fine. But the square root of negative 1? I. I'll write that part second. What's the square root of 9? 3. Does that now match what we got with factoring?
Yes, sir.
That's what I want you to notice is that will give us the same information.
what was the quicker way of doing that? What was the quicker way of doing that?
In my opinion,
Yeah, you showed it. Like, what was it?
like simplifying here or solving?
Like, that right there.
Just looking at it? I mean the quicker way is recognizing the square root of a negative is I and the square root of 9 is 3. Like I would do that in my head. I'm showing you all the steps though to get there.
But there was the example. Like,
If
from
you
the
know.
square.
If it's a perfect square, right? So to answer your question, like if I have the square root of negative 25, I know the square root of a negative is I, and I know the square root of 25 is 5. Is that what you're asking? But you would have to explain it that way, or you show me that way to justify your response. Okay? So it's your choice which one you do from there.
So if it's not
So if it's not a perfect square, you all want me to show you
Yes, sir.
if it's not a perfect square really quickly?
Yes, sir.
So remember, if it's square root of negative 54, and this is again why I show you this method, because this will always work. Well, I'm going to factor that into negative 1 times Are there any factors of 54 that are perfect squares? None? Y'all didn't even take time to think.
You just said that, you just said you was gonna do one that wasn't perfect square.
Thank you. But that doesn't mean that it's not going to have perfect square factors. None of these numbers I've written down are factors of 54.
Which ones are?
I don't know, use a calculator, figure it out. Because I'm not telling you on an understanding checker test. 9. 9 times what gives me 54?
Times 6.
Oh, yeah, I thought you
Oh.
said square, I thought you said something square.
I said, are there any factors of 54 that are perfect squares? So I will factor it out into all of those. So the square root of -1 times the square root of 9 times the square root of 6. The square root of 9 is 3. I can't take the square root of 6, so I leave it as square root of 6. Square root of -1 is I. Remember, the I always goes at the end of the real number.
Right.
That's it.
Plus I, sorry.
If I was solving an equation. So if it had been x squared equals -54, yes, it'd be plus or minus. But remember, when I just simplify, it's just whatever the symbol is in front. It's only when solving, when you take the square root, that you get a plus or minus. Good question. So, let's look at B. Actually, let's focus on, let's look at B. Let's do this. I'm going to have different groups do different parts. Group 1, I want you to do this part right here, and I'll explain more details about this in a second, so know which one's doing what. Group 1 you're doing if A is positive and C is positive. Group 6 you're going to do when A is positive and C is negative. And then, let's see, group 5 you're going to do when A is negative and C is positive. Group 4, I want you to do C is negative and A is negative. Group 2, I want you to also do C is negative and A is negative. And group 3, you're going to do both positive. Now, where do you think I'm getting this A and C from?
The AC.
Right, ax squared plus c is equal to 0. Notice that's standard form, we're just missing bx, right? Assuming that b is a 0, right? That's what that's doing, okay? So, what we are trying to determine, right, is when the solutions, notice we do have an equation now, when the solutions are real or when they are imaginary. So you as a small group, depending on which one you have, need to identify a value for A, if you're in this section, where A is positive, and when C is positive. So I'll do one for this group 6. You have to use a different one, okay? But since you're the only group doing that, if A is positive, what's an example of that?
5.
Okay, so 5x squared. C needs to be negative, so give me an example.
Minus 25.
Minus 25, or minus 2, whatever, equals 0. So that is an example of the structure when ax squared plus c is equal to 0, and A is positive and C is negative. And you need to figure out, are the solutions to that going to be positive, or are they going to be real or imaginary? Anybody know how we could easily do that?
Solve it.
You could solve it, you could see if you could factor it. What else? You have multiple options. When you say calculator, what do you mean? If you graph it, you can also figure out if the zeros are going to be real or imaginary. So I don't care how you approach it, it's your choice, but I need these groups to develop an equation that follows that format, and then I need us to come back together in a few minutes, figure out if your section has real or imaginary solutions. If you need clarification as a small group, let me know, but I'll be coming around.
So, let's write it down.
How do you solve it? Right box.
You gotta solve it. Procedure like this today, procedure like what's a wake up. I'm sorry, I'm just playing. I'm just playing.
Group 3, y'all have when A is positive and C is positive. Come on.
Yeah.
Figure out those solutions, real or imaginary.
But we gotta do something.
Okay, does that work? Negative 2x squared minus 36. You're going 4, it needs to be negative, C needs to be negative. All right, there's one example. Let's find a couple more and let's test them out, see what kind of the solutions we get.
Actually, we should do x squared. Right, 6x squared. 7 squared, 6.
So that ain't gonna work.
I mean, it can work, but x squared minus 36 might be easier. Maybe do both of them. You're also trying to do it algebraically. We already said, what else could you do?
Graph it.
So maybe you do x squared minus 36 and 6x squared minus 36 and see what you see.
Okay, somebody put one of them in the calculator, and then somebody else did the other one on paper. I'm already halfway done.
I'll say this, I feel like y'all
I do a 6 left, so you do it.
So y'all are trying to solve it algebraically. How else did you try to solve it though? I would probably. Because if it's going to be a real solution, what are you going to say? When you say 0, what
X
are you
squared.
Yeah, because I'm not getting
For the
How do you
6
know when you have
one.
words?
I don't know when it's
And intersect.
Oh, I didn't do experiment.
I don't care about it.
I'm sorry.
I was telling you
Well,
which group.
I got 2.4.
Did y'all figure out real or imaginary?
You said what?
What equation did y'all solve?
Yours? I got 2.
No, don't use mine. One, A and C are positive. Two, you're supposed to create your own. And sucks to
So X squared.
So what equation did you use? You can't have used mine. Your A needs to be what? Positive. Your C needs to be what? Positive.
Give me your ratio.
Give me an example of an equation where A is positive and C is positive.
Bruh, this is the only one I grab this morning. I'm gonna need to mind your business.
5x squared plus 1.
Then you're gonna try to wake up and try to run it. Like, what are you doing? You did it too for me. I was over here trying to do this. I'm sorry. Okay, so we doing.
Yes, sir.
Sadly, I dropped it like 8 times. But I got up this year.
I can look later.
And then one of my wheels fell off. Jaden, leave me alone.
You're just supposed to determine if the solutions are imaginary or real. Yeah, look at the graph. So like,
You want
look
the Jane?
at, no, there's your parabola. Are the solutions real or imaginary? You could have solved it. You didn't have to though. Because you can just, you're just supposed to determine if they're real or imaginary. That's it.
No, that's anyways, so that this plus 6.
Graph it. Thank you. Thank you. So it appears based on conversations that most of us are already done, so let's have some discussions about this. Because I want to emphasize, remember there's 4 different cases. When A is positive and when C is positive, you would identify if it's imaginary or real. When A is negative and C is positive, you're identifying if it's imaginary or real. Okay, so we have 4 different cases, right? A is positive and C is positive. Group 1, who's the other group I had on here? 3. Did y'all decide if it was going to be imaginary or real? Imaginary? What did y'all decide? What? Why imaginary? Y'all seem not confident in that statement. So I'm writing it for now, but let's see.
Ain't
You
nothing.
can't just,
You ain't even.
wait, hold on, I want y'all to hear this conversation. Listen, you said nothing even popped up when you graphed it. Okay, I'm not saying you're wrong,
Yeah,
now,
zoom out.
okay, listen, so what did you say, Caleb?
Zoom out.
Kadeja, I'm trying to teach, listen to him.
You're not using
Caleb, what did you say again?
You had to zoom out.
You might have needed to zoom out, okay? Maybe not enough, okay? Hey, stop and listen. Stop and listen. Shh. And listen, okay? 5x squared plus 25 is the one y'all used. I'm going to talk about two really important things that we should notice. First off, if you don't see it on the graph, then is it intersecting the x-axis?
No.
So then the roots would have to be
Imagine.
imaginary. But also look, we can solve this equation. What would I do to solve this equation?
Minus 25.
Minus 25.
Then you can write 5x squared equals
So 5x squared equals what?
negative 25.
We good with that, Jake? Okay. Now,
Multiply by 1/5.
multiply by that 1/5.
I wouldn't did it.
You would probably divide it, wouldn't you?
Yeah, it's squared.
So x squared equals negative 5.
Square root.
Now square root. So x would equal plus or minus. Well, square root of negative 5, but that would be square root of 5 times I. Remember, that's negative 5, that's square root of negative 1 times square root of 5, or times 5. Square root of negative 1 times square root of 5, which is square root of 5 times I. So, what kind of roots are they?
Imaginary.
Imaginary. Did you know that we didn't have to do any of that work? In fact, you didn't even have to graph this on the calculator. And I want you to pause and I want you to pay attention to this and think about the structure of this. If we're using inverses, you're implying that this quadratic is in what form? You're implying it's in vertex form. And so remember, in a situation like this, you can see it as both standard and vertex form. But if you're thinking about vertex form, you should also be thinking about what other main idea that we have studied this year. What's that multiplication going to do? What's the subtraction and the addition going to do?
A lot. Multiplication dilates.
Multiplication dilates. What else?
Reflects.
Then we have reflections if we're multiplying by a negative. Addition and subtraction creates translations. We want to connect these things to the transformations. So look again at the idea of 5x squared plus 25. The parent function is just x squared. I'm just drawing a sketch. There's x squared. But if I have 5x squared plus 25, what's going to happen to it? Anybody see a translation?
It's gonna
translate to right. 25.
Okay, do y'all agree? Translate to the right 25? Translate. Notice it's outside that square, so it's going up.
And then
That's my vertex.
Been multiplied.
The 5 and the x will be multiplied, but more, we want to notice, it's going to stretch, but it's going to stretch which direction? Up, because it's concave up. Without even graphing, I already knew, is it going to intersect the x-axis? No. So the roots had to be what? Imaginary. Use the structure, use transformations to your advantage to understand how these would look even before you start to graph. Okay, so which group did I have working on this one up here? Which group was this? Group 6? What did y'all decide on the types of roots? So, sounds like someone's getting murdered out there.
Imagine somebody used maybe just.
Not our problem.
Okay. It's a little dangerous mindset to have, but Tracy, what did y'all decide for this one?
Real.
Y'all decided real?
What did we decide?
Yep, what a reason.
There we go. What's the reason? So, what equation did y'all develop? X squared minus 36. So again, you can solve this, but let's think about it just from the structure. What translations do we see?
Down 36.
Down 36. Which direction is the concavity? So is it going to have real solutions?
Yeah.
100%. notice and pay attention to those translations to just help you determine, are they going to be real or imaginary? That's an important part about that vertex form. Okay, who was working on A is negative and C is positive? Group 5, what did y'all say? Real? What equation did you use? Negative x squared, 10x squared, minus 5, plus 5, thank you, equals 0. And so I want to point this out, and y'all were solving this, and I came over to your group and I even said, yikes, that's not going to be fun to solve. You can totally do it, right? But I suggested you graph it, I want you to think about it now. What transformations do we see here? Okay, it's going up 5, and it's going to be concave down. So is it going to have real solutions? Yes. Just paying attention to the concavity and the different features that we know will really help you in understanding these. The last one, A is negative, C is negative. Group 2, we all work on this? What'd y'all say? Imaginary. Group 4, y'all said? Imaginary. And so give me an equation that y'all use. Equals 0, right? And so you would have to zoom out really far for this one, but what transformations do we see? It's concave down, and it's translated down 36, and then concave down?
Yeah.
Yeah, is that ever going to intersect the x-axis?
No, they're going all the way.
Right? It's going the other way, fool. So yeah, right? So the solutions are going to be imaginary.
What's his name is again?
What time is it?
It's going the other way, fool. I just found out how to keep your baby awake, y'all. Okay. So what are y'all's questions about whether they'll be real or imaginary? We good? Through here. Straight on. And so again, I want you to pay attention. Noting the structure, paying attention to transformations will make your life significantly easier. So for example, number 4 here. Number 4. How can you use the structure of this function to determine whether its zeros are real or imaginary?
You grab the transformations, man.
Okay, so before even just graphing it on a calculator, think about your transformations. What transformations do we see?
Up one.
Up 1 and to the right 2. Notice this is also vertex form. The vertex form tells me my transformations. Now, what's the concavity going to be? That A is a positive 1, so it's going up.
So is it on there or is it?
That's the x-axis right here. That's 1 up.
So it's imaginary.
So those zeros are going to be imaginary. That's huge to notice. This is mathematical thinking. This is what I've been trying to get y'all to do all year, is think through, oh, well, because of these details, I already know blank before even having to use a calculator, right? So how can you use the structure? Well, think about transformations. When the function is in which form?
Vertex.
Right. Okay. So think about those transformations when the function is in vertex form, and just picture if it intersects the x-axis. If it doesn't intersect the x-axis, those zeros are going to be imaginary, right? There's beauty to this. It's going to be quick and efficient. And I also want to point something out, and I hope that this is something, whether you're junior or senior, whether you plan on studying math or don't plan on studying math, because I assume a lot of us are at one point, one day, are going to have children. I hope that something you take out of my classes is anything in math isolated.
No.
It all connects somehow. Equivalence is an idea that has come up time and time again. This idea of transformations ties into the vertex form. Everything in math has connections, and when you look for the connections, one, it makes it beautiful, or at least more beautiful, Jake Juan, right? It makes it more beautiful, and that's why every now and then I can get you to smile in my math class.
Math is art.
I don't know about beauty.
There is beauty to it, for sure. So let's look at 4b. What is the solution to x minus 2 squared plus 1 equals 0? Let's push back on the language of the textbook. What is wrong about that?
What are zeros? Should we change it to zero?
Does it have to be a 0 this time?
No.
Because, I mean, can I find what makes this equation true? Yeah, it's not a function. I can find what makes the equation true. But there's another issue. There is an issue. There's an issue with the way the book is wording this
What is
question.
the zero?
Remember, we just said it doesn't have to say zeros.
Wait.
What are the root?
Wait.
Wait.
There's, the what is okay. Why are you saying solutions? Mark, yeah, I'm just getting what here. You're saying, huh?
8 to 0, so I don't have to 8 got the 0.
Oh, I know.
You guys got square? The square, fool.
Square root.
Square, you fool. So what were you saying though, Chloe, before I...
It's quadratic.
It's quadratic, so what? Oh, it's quadratic, so it has to have two solutions, right? And so when I take the square root, I'm going to get both a positive and a negative, right? So I want y'all to notice those details. So what are the solutions is what we should have said here. All right, work within your small groups. Find the solutions to that. Oh, it must be so hard to use inverses to undo operations.
If you were listening, you're supposed to find the solution. I'm not even stuck.
If you want to do math in college, you better start thinking the way I think.
You're supposed to find the solutions to this.
You're capable of it, you just got to fall asleep.
Yeah. Wait a minute. Yeah, probably some trick one.
This is the third quarter. Yes, you can subtract. When you add a negative, it is subtracting.
Why is you playing?
Come on, let's keep going. I do like the mathematical talk.
It's talking. You get on my nerves.
Huh? Does anyone know how to go from x minus, so instead of just erasing it, what did y'all do in this case right here?
If they don't fit,
Come on, Liam, Sean, we're small group, we're helping each other grow and learn. What do you do from here?
if they don't fit,
Squared or square root? So it took square root, right? We had to, because the square root and the square cancel, x minus 2 equals what? One second.
Square root only one is 2. Or
So remember, the square root of negative 1 is I. Now you're forgetting one detail, that the square root of negative 1 is I. What? What?
Okay, so
Yes.
you're
This is an important detail in that equation. Come on, we haven't even started with all of this.
so special in math.
Thank you. Be attentive to details. How are we going to solve
So
this?
special.
Huh?
Yeah, you can.
But can you see the zeros on that graph? It's not, it doesn't have any real zeros, but they would have to be imaginary. Can you see imaginary zeros on the graph? So what can you do to solve that equation?
But it
Remember,
would
it's
be
in vertex form. You can use your inverses to solve it.
Not two,
Well, it's gonna be 3.
because it's two solutions.
How's it going?
Just a real part.
Trying to factor it? Can you factor this?
You know that real one?
I didn't even start it.
I know what the fuck it is, but why you trying to rub it like?
Chloe's at least started. I might have talked to her.
No, Jacob is trying it today.
It's not in factor form.
He
So what
deserves it.
You killing me?
It's in vertex form, so what can we do to do vertex form?
I already got mine. I want
Using what?
Okay, 2 plus 5.
Right, if it's in vertex form, you can use your inverses with your properties of
I don't
equality.
know what to do with that. I just found it in our backyard.
We have.
Well, in the shade. I do have hard ones, but we got less. Yeah, they do.
Inverse of the square.
I don't, in my car, it's so
I asked you a question.
And I just threw it back out.
I asked you a question.
Push it in my car. Bruh, I wanted to be
Thank you, thank you, thank you.
I wasn't bringing it.
I have noticed a couple of really important discussion points. Excuse me, when I say thank you, I know you heard me, please stop talking so we can learn. I saw a couple of really important discussion points. First off, I saw Tyrese, he graphed it, right? Which we already had a sketch of it, but Tyrese, what's the issue in graphing it? You can't see those imaginary zeros, right? So when you have imaginary zeros, can you graph it to solve? No, right? Juanicia started to try to factor it. Can you factor though when there are imaginary zeros?
No.
If I were you, I would make a note here somewhere next to this problem when there are imaginary zeros. You cannot what to solve? You cannot factor or graph to solve. That's huge and really important to notice. You cannot factor or graph to solve. So what are the methods available to us? What do you need before you can use inverses? What form? Vertex form.
Yeah.
Can use vertex form with inverses and properties of equality. What else could you probably use then? If you have standard form, you have to use something with it. Say it louder for me. Oh, that quadratic formula! Look at there! This is important to notice. The only way to solve quadratic equations with those complex or imaginary zeros, you have to use inverses and you have to use or the quadratic formula. Now, because I already have vertex form, I'm using inverses. Go ahead and start in this first step because everyone was good here.
I'm glad you started
Now,
thinking before I did.
I need your eyes up here.
Okay.
I need your eyes up here, especially if you already have that note down. Remember, we're using the inverses in the honestly opposite order of how they're applied. So when I look at x, what's the first thing happening to x?
-2.
Subtracted by 2. After we subtract by 2, x minus 2 is being squared. After we do x minus 2 squared, it's being added by 1. That's why we subtracted 1 first.